Hi, this is Professor Fernandez, and we are working here on class note C in lesson 8. So my goal in the previous video was to introduce you to the elementary row operations, and we did that by solving a particular example. That's the one I reproduced down here. My goal in this video is to basically redo all that work, but using what is called an augmented matrix. And you'll see in augmented matrices that just like what we realized with solving linear systems with row operations, really all we care about is manipulating these coefficients, right? We don't really care about x and y. We kind of just carried it along for the ride. But it didn't really matter insofar as we wanted to find get to a point where we said x equals 5, y equals 5. So the point of augmented matrices is to recognize that fact and to say, you know what, if I were to translate this system into ax equals b form, like we did in the first video in this lesson, then the A matrix is the coefficient matrix, remember? So there's a 1 here, there's a 1 here, this is the coefficient of x here, coefficient of y here. So this is the coefficient matrix for this system. And then I have x, y, and then I have the right-hand side 10, 3. So the augmented matrix way to solve this problem starts off by keeping the coefficient matrix, 0.2, 0.4, keeping the B matrix, and then just putting, you'll sometimes see a dashed line here, sometimes you'll see a solid line. But the point is you get rid of the vector xy, right? Because if I scroll back here for a moment to the work we did in the previous video, right? Again, this is what I'm showing you, that in every one of these steps, the x's and the y's are just going along for the ride. The only thing that is changing are the coefficients in front of x and y. So in this particular step, the coefficient in front of x was a 2. And then by this row operation, it changed to a 1. And then by this row operation, it just disappeared, right? So the way that those coefficients and those variables disappear is by changing the coefficients in the equation. So that's fundamentally what the augmented matrix approach recognizes. So what I'm going to do here is now show you how to solve the system from this augmented matrix form using the exact same row operations we did before. Actually, they may not turn out to be exactly the same. I may forget the order that I did them in. But okay, first thing I think I did was recognize that in the second row, I don't want to have these decimals in there. So I'm going to multiply the entries in the second row by 10. Okay, so I am not changing the entries in the first row of this augmented matrix, and then every single one of these terms in this augmented matrix gets multiplied by 10. So I get 0.2 times 10 is 2, 0.4 times 10 is 4, and then 3 times 10 is 30. So again, notice that at any point I could back out to the linear system by writing everything out, right? This is the new coefficient matrix, and this would be the coefficient of x, this would be the coefficient of y, this would be the coefficient of x, this would be the coefficient of y, and then this would be the coefficient of the right-hand side of the first equation. This would be the coefficient of the right-hand side of the second equation. Okay, so the point in me showing you that is that at any point you can convert back from the augmented matrix to the linear system form or vice versa. Okay, so the augmented matrix is just an efficient way of keeping track of what matters for solving the system, which are the coefficients. Okay, next thing operation I think I did was I looked at the second row and I said, oh, every term here has a 2. Factor of 2 in it. So I'm going to multiply the second row by 1/2. Great. I don't change the first row, and then I just divide everything by 2. So 2 divided by 2, that's 1. 4 divided by 2, that's 2. 30 divided by 2, that's 15. All right, sounds good. And then I recognized, oh, so it looks like I might be able to eliminate the x's. Now, in augmented matrix form, there are no more x's or y's or z's or whatever the variable names are. So how do I know what steps to take? And that's part of what's covered in this next lesson notes, right? But we're going to fast forward a little bit here. if I were able, through a bunch of row operations here, to get the system to look like this, right? To get the augmented matrix to have this form. Let's say I have a number here B1, a number here B2. Then, just like I had talked about a minute ago, I could convert this into the system of linear equations form. This would be the coefficient of x. There would be no y because it's plus 0y, and it would be equal to B1. And then this would be the coefficient of x. There's no x. This would be the coefficient of y, so just y. It would be equal to B2. In other words, if I am successful in getting the augmented matrix to this particular form, right? What I mean by this particular form, the first column has a 1 and then a 0. The second column has a 0 and then a 1, right? If I can get the augmented matrix into that form, then I can just literally read off the solution, right? I will say x equals B1, y equals B2, right? So that's kind of where we want to head with this, next few steps in the augmented matrix that we're about to do. So that is going to motivate the next step that I'm going to do here. Excuse me. I have a 1 here. I would like this to be a 0. Okay, so the way I make that a 0 is by the exact same step that I used last time. I'm going to say replace our row 2 with row 2 minus row 1. Okay, so I'm going to leave the first row unchanged. So that's 1, 1, 10. And then I'm going to subtract 1 minus 1. I get 0. There it is. And then 2 minus 1, that's 1. And then 15 minus 10, that's 5. So you can see how I succeeded in making the first column of this augmented matrix into the column that I want, 1, 0. Great. So now I want to move over to the next column and work on this second column, right? And I wanted this to be a 0 up here, so then I could just read off the solution. So that's going to motivate the last row operation that I am going to do. I'm going to say, okay, row 1. I'm going to replace that with row 1 minus row 2. Great, so I'm not changing the second row. I'll just write that over. I am going to change the first row. I'm going to take 1 here and subtract 0. Gives me 1. Take 1 here and subtract 1. That gives me 0. There's a 0 I want. And then 10 and subtract 5. So that gives me 5. And sure enough, I, through the sequence of judiciously chosen row operations, have now gotten the system to the point where if I write it out in its linear system form, I can just literally read off the solution. X and Y are both 5, which is the same solution that we arrived at in the previous video. So to recap the steps here, right? What is the point of augmented matrices, right? You take the initial linear system over here, and by extracting from it the coefficient matrix, that goes in this matrix. And then just a separator here to remind you that all the numbers over here are the coefficients of the linear system. And all the numbers over here are the right-hand sides. Okay. So then you take the coefficient matrix, you plop it in here, and then you take the right-hand sides, you plop it in here, and then you do all the same row operations that we would have done, except now we're not carrying around the x's and the y's anymore until the very end, right? And then your goal is to get the system in augmented matrix to this point where the first column has a 1 in the first row and then zeros everywhere else, however many zeros there are. And then the second column has a 0 in the first row, 1 in the second row, and then zeros everywhere else. If you do that, then you can just start reading off the solutions. Okay? So I'm going to fast forward a little bit to show you what that general n form that you're looking for looks like. Right? That is the general n form here of the augmented matrix that you're looking for. There, whatever variables it may be, this is the coefficient of x, it would be equal to S1. This is the coefficient of y, it would be equal to S2. And then maybe down here, this is the coefficient of, I don't know, x sub n, I say down here. This is equal to S sub n, whatever number that is. All right? Great, so that's a quick little overview of augmented matrices, how they work, and what you're looking for.